right, so we're still in organic chemistry. This is our second lab in organic chemistry, and it's esters. All right, so esters, you might recall, are our first derived functional group. All right, so we make it from an alcohol, all right, and it could be primary, secondary, or tertiary, and a carboxylic acid. So the cool thing here, it's probably one of the coolest labs you're ever going to do, because you're going to start off with a horrible smelling carboxylic acid. So the carboxylic acid functional group looks like this right here. All right. Now we're going to be using vinegar today, or concentrated vinegar, ethanoic acid. That is the best smelling of the carboxylic acids. Some of them just smell absolutely rancid and horrible. Think of like well-worn sneakers that have been, someone just played 2 hours of basketball in them. Those would be carboxylic acids, literally. And then we have sort of sweeter smelling alcohols. So we've got that OH functional group. Well, these are going to come together here, and they're going to form H2O. They're going to form water here. So we're going to take the OH from the carboxylic acid and the H from the alcohol. We're going to form water, and we're going to form a sweet smelling ester. All right, so from this kind of horrible smelling, I guess from all these functional groups with all these different smells, we're going to come out with something really nice. Okay, so when I was in high school, we had all this great glassware, and we had separating funnels, and we had water jackets, and I think it was like $1,000 each. And today we get replaced by about a 3-cent tube, all right, which is perfect, because we're going to be putting and the order is important here, carboxylic acid in first. Then we're going to put our dehydrating agent, which is our concentrated sulfuric acid. And then the alcohol last. All right, why the alcohol last is for safety, because it's the last thing in the stem. Anything that's going to spurt out, we want it to be the alcohol. All right, it's the least harmful of those ones. Definitely not the sulfuric acid. And nobody wants vinegar against their skin, concentrated vinegar against their skin. So we're just going to introduce these one at a time. This reaction does take place in the gas phase here. That's where the reaction happens, right about there in the tube. All right, and that's why we have to get this temperature up to, and we're right at 85 right now, and that's the minimum temperature, and we need about 15 minutes. Okay, so let's get started with our vinegar. Very strong smelling vinegar, by the way. So we're just going to introduce just a little bit. All right, so there we go. We've got our vinegar right there. Let's cap that just to keep the odors down. And now, this is the part where students get always a little bit nervous, is the concentrated sulfuric acid. That's reagent sulfuric acid, about 18 molar. So yeah, so just a couple of things. Safety tips is, don't want to get this on your clothing. If you get it on your skin, put it under water for 60 seconds, all right? If you do get it on your skin, because it won't burn right away. But if you get it on your clothing, you'll ruin your clothing, all right? So here we go. I'm gonna put just a little bit of conc sulfuric in here, just as it reaches the top there. That's perfect. And I'm gonna let gravity, pressure, pull that in. And I can feel that it's getting a little bit warm, like right off the bat. I can feel that with the ethanoic acid. It's getting a little bit warm. Now I'm gonna add the pentanol, which is my alcohol. Right, I'm just gonna squeeze that out. I'm gonna place this in. Okay, so since the reaction does take place in this gas phase right here, I'm going to place this in, and we're going to check in after about 15 minutes. All right. Okay, we're 15 minutes, and sometimes you get separation, sometimes you don't get separation. but in this case we have. All right, so notice that we've got this nonpolar ester layer at the top, and we've got this aqueous layer on the bottom. All right, so this is really good. Sometimes it might be just one big soup, and maybe just the shock of putting water in there, or it's hot, so we can put it into ice water just to cool it down. Why? Just reduce solubility. All right, it's cooler, it just doesn't dissolve as well. But ours is already separated. So what we're going to do is I'm going to get rid of the aqueous layer. Now, aqueous layer here is very easy, just a separating funnel now. What I'm going to do is turn that over. And I have a very, very fine line between the water and the aqueous layer. And there it is. So I have just the ester layer. I didn't make a lot, but it's a qualitative lab. So I'm going to squeeze out some air. I'm just going to introduce some water here. I'm going to mix that. It's like salad dressing. This is like water and the less polar ester. I won't say non-polar. Now, you might recall just from notes and from looking at esters, esters are excellent solvents, which means they like to dissolve things, not react with them, dissolve them, which means we have undissolved, so we've got dissolved, unreacted pentanol, 1-pentanol, and ethanoic acid. So let's leave that a second for it to separate. And we can see just we're getting a nice ester layer on the top. We'll leave a second for that to separate. Sort of a rich ester layer there on the top there. And let the water act on it and have that OH of the water. So I want to have this OH here start to pull out unreacted carboxylic acid and unreacted, sorry, there's my alcohol and my unreacted carboxylic acid. So that's what the water's for. It's not water because it's plentiful, it's because it's polar, all right? So we want to, it won't dissolve in water, but that will get rid of the, anything that's unreacted. So that's settled just a little bit. I just want to get just that top layer. All right, so we have a little bit less. That's good. I know it seems like, oh, man, we lost some. That's fine. All right, just because our ester's more pure than it was before. All right, so let's do that again. Let's get another rinse. So we're just going to let that separate again. It's like shaking up a salad dressing bottle. The ester is going to less dense, move to the top. The aqueous layer, more dense. It's going to eventually make its way to the bottom. Trying to remove as much of the unreacted stuff as possible. Can turn this off now. Yeah, so just get it above 85 for 15 minutes is enough to make, like, enough ester to make a difference here. Yes, that's pretty rich on the top there. Just that top layer there. All right, there we have our odor here. All right, so I guess one of the parts of this lab, everyone sort of makes a different ester. So we have all sorts of odors in the classroom, wintergreen and banana and orange, depends upon, you know, what students make. So we've got, we have a really nice fruity, kind of like almost like banana-like odor here. So this is our, again, this is our 1-pentanol with ethanoic acid. All right.